Let's look at the OSI stack from computer networks. So, switching on our smartphone and sending an email to a friend that lives about 500 kilometers from our home is actually something we take for granted. And we just do it and it seems easy, but it involves a lot of very complex processes and has to take into account a myriad of different situations. And so, as any engineering problem, the best solution to tackle such a complex thing is to break it down in a series of smaller problems that are easier to solve and assemble a solution later. One way to do this is to make an abstraction and separate different functions of a computer communication process in layers, considering that a layer communicates with the correspondent layer and the other layer by using the surfaces of the layer that lies immediately under it without knowing anything of what lies below that and how it works. That way, the programmer of software that manages that layer only has to deal with how to communicate with its partner layer in the other computer, and how to use the surfaces of the layer below, being completely isolated from the rest of the processes involved in the communication, and hence the difficulties. So one way to do this is the OSI, the Open System Interconnection Model, which has divided up the problem of communication into 7 abstraction layers. It defines a networking framework to implement protocols in 7 layers. And control is passed from one layer to the next, starting at the application layer in one station and proceeding to the bottom layer over the channel to the next station and back up to the hierarchy. The OSI model doesn't really perform any functions into the networking process. It's a conceptual framework that allows the complex problem of computer internet to be broken down into smaller, more manageable problems. So this OSI model you see here on the slide takes the task of internetworking and divides it up in what is referred to a vertical stack that consists of 7 layers that you can see here. So at the bottom there's the physical layer, on top of that the data link layer, we have the network layer, the transport layer, the session layer, the presentation layer, and finally the application layer. So these are again divided up basically in 2 sets, and we're going to look at each one of them. The first set is the application set, and it consists of the 3 top layers of the model. And this set deals with the communication between applications in the 2 end computers, and its 3 layers manage data not yet divided in segments or packets. So the top layer is the application layer. So the application layer supports application and end-user processes. Communication partners are identified, quality of service is agreed upon, user authentication and privacy are considered, and any constraints on data syntax are identified. Everything at this layer is application specific, and it provides application services for file transfer, email, and other network software services. So Telnet and FTP are applications that, for example, exists entirely into the application layer. So below that layer is the presentation layer. This layer provides independence from differences in data representation, like for example encryption. And it does this by translating from application to networking format and vice versa. So the presentation layer works to transform data into the form that the application can accept it. This layer formats and encrypts data to be sent across the network and providing freedom with compatibility problems. So it's sometimes called even the syntax layer because of that. So the last layer in this application set is the session layer. This layer establishes and manages and terminates connections between applications. So the session layer sets up, coordinates and terminates conversation. It exchanges and dialogues also between the applications at each end of the communication channel. It also deals with session and connection coordination between one application and its counterpart in the other computer. So the next set of layers are the remaining 4 layers, which is called the transport set. And it consists of the remaining layers of the model and deals with all the processes that we need when communicating in a computer network. So these layers work with smaller chunks of information that are created to facilitate the communication of internetwork, as we explained before, was needed. So the upper layer of this transport set is the transport layer. And this layer provides a transparent transfer of data between end systems or hosts. And it's responsible for end-to-end error recovery and flow control. And this is actually the lower layer that works between end computers, and it ensures complete data transfer. So below the transport layer is the network layer, and this layer offers its services to the transport layer, which is on top of it. It provides switching and routing technologies, and it provides managing multi-node networks. It creates logical paths, so it's virtual circuits, and it can be used for transmitting data from node to node. So routing and forwarding are functions of this layer, as well as addressing, internetworking, error handling, congestion control, and packet sequencing. And this layer does not only work in end computers, but it also works with intermediate network devices. So approaching the communications hardware going down in the OC model, we find the data link layer. And the data link layer is in charge of direct communication between two adjacent nodes. And at this layer, data packets are encoded and decoded into bits. And it furnishes transmission protocol knowledge and manages and handles errors in the physical layer, which is below. It does flow control and also frame synchronization. So the data link layer is divided again in two sublayers. One is the media access control layer, which is the MAC layer, and the logical link control layer, the LLC layer. The MAC sublayer controls how a computer on the network gains access to data and permission to transmit it. And the LLC layer controls frame synchronization, flow control, and error checking. So then finally, the layer that controls communication with the specific hardware is called the physical layer. And this layer conveys the bit stream, which is an electric impulse, light or radio signal, and through the network at the electric and mechanical level. So this layer provides the hardware means of sending and receiving data on a carrier, including defining cables, cards, and physical aspects. So gigabytes Ethernet, RS-232, DSL, or ATM are protocols that you can specifically find at this physical layer component. So to look at an example of how these different layers are implemented in different devices, here we see on the slide, for example, a router that is able to connect different networks. So a router that is able to connect different networks only goes up to the network layer because it doesn't need to go beyond, because the application layer is at the host. A switch that works inside a local network only goes up to the second layer. And the host applications, obviously on this side and on the other side, they have to all go up to the application levels and do the 7 layers. So with the widespread use of the internet, the simple TCP/IP protocol stack has become the de facto standard in internet networking across the world. And so the OC model is no longer used to develop communication software, but it's still very useful in education, since the abstraction layers make it simple to differentiate how network communication works. So we can see its use when system administrators troubleshoot a physical a network problem, for example. So first of all, they say, is it physical problem? Is your network cable plugged in? Then they go on and say, is it a data link problem? Do you have a link light in the network card? Then the third thing they can look at is that the network problem? Is the PC getting any IP address? Then the fourth thing is with the transport. Can you ping your default gateway, would be a specific question at that level. And then we can look at the session and we can ask questions like, well, do you have a DNS server information and can you ping 4.222 but not, for example, ping google.com? And finally, if this all doesn't work, they can ask questions in the presentation and application layer, like for example, can you reach a website with your web browser? So the OC model still is very useful in trying to understand how it all works because of these 7 abstraction layers. So we have seen the OC stack in this video.